Hi guys, welcome back to this channel. In this video we are going to explore the topic artificial intelligence, and this is one of the most exciting growing areas in computer science. Now let's look at the meaning of artificial intelligence. So artificial intelligence, which is AI, is a branch of computer science dealing with the simulation of human intelligence, intelligent human behavior by a computer. So basically it focuses on mimicking the intelligence of a human being, and this is often referred to as cognitive functions of human. So when we say cognitive functions, we're talking about the ability for the system to reason, for the system to learn, for the system to be able to solve problems, for the system to be able to recognize speech and vision. So all these functions can be replicated in a machine, and they can be measured against human benchmarks such as reasoning, speech, and sight. So can it recognize speech like a human being? Can it make decisions like a human? Can it see and interpret images like a human? If the answer is yes, then we are moving towards artificial intelligence. Okay, now let's look at the characteristics of AI. So AI is a collection of rules and data, and the ability to reason, learn, and adapt to external stimuli. So AI are built using collection of data, large amount of data. They have the ability to reason on their own, the ability to learn, and then the ability to adapt to a new situation. And AI can be split into three categories. The first one is narrow AI. So this occurs when a machine has superior performance to a human when doing one specific task. Basically, it is when a machine performs one specific task better than human. So this is narrow AI. Then we have general AI. So this occurs when a machine is similar, so it is not superior, in its performance to a human doing a specific task. So the performance is at the same level to a human in a specific task. And then we have the strong AI. So this occurs when a machine has superior performance to a human in many tasks. So this would perform better than humans in many different tasks. So currently, the strong AI does not fully exist yet. It's more of theoretical concepts. Okay, now let's look at how AI reasons. So one of the most important characteristics of AI is reasoning. And we say that reasoning is the ability to draw reasoned conclusions based on given data or situation. So AI is often uses what we call deductive reasoning, and it starts by knowing the facts. Okay, so it needs to know the facts, which to form a set of rules which can then be applied to other problems. So it starts by knowing the facts, then it builds up the rules, then it applies those rules to new problems. So for example, if AI is used to produce the perfect cup of tea based on a number of facts, the machine will learn from the experience and apply its new rules in the making of a cup of coffee, hot chocolate, and then modifying its methodology when necessary. So if an AI learns how to make a perfect cup of coffee by analyzing data such as the temperature, the brewing time, the amount of milk, it can then use similar logic to make coffee or hot chocolate by modifying the rules slightly. So this shows learning and adaptation. So by carrying out a sequence of steps, the AI machine can learn, and then the next time it will know how to do the task more effectively and even apply it to any other situation. So we say that AI system is capable of learning and adapting to its surroundings, and AI can very quickly discern patterns and then make predictions by adapting to a new data. Okay, now let's look at the two main types of AI system. So we have the expert system and then we have machine learning. Now, what is expert system? So it's a computer system that mimics the decision-making ability of a human. So expert system uses AI to simulate the judgment and behavior of a human or organization that has expert knowledge and experience. So basically, this system is designed to mimic the decision-making ability of a human expert. And then we have machine learning. So it is the science of training computers with sample data so that they can go on to make predictions about new unseen data without the need to specifically program them for the new data. So it's just this system uses sample data so that they can make predictions about new data and we don't have to explicitly program them. So let's look at the applications of expert system. What are expert system used for in real world? Okay, we have prospecting for oil and minerals. We have diagnostics of faults in a car engine, faults on a circuit board. So if you want to know what is wrong with a car, you can use an expert system. We have medical diagnosis. So we can, in the expert system, we can input the user symptoms and it will give us the diagnosis. Okay, we can use expert system in strategy games. We can use it in tax and financial planning. We can use it in route scheduling for delivery vehicles. And then we can also use expert system in identification of plants, animals, and chemical compounds. Now let's look at the advantages of using an expert system. Number one, it has high level of expertise. Now, the information that is stored in an expert system, these are data that are gotten from different expertise, data that are gotten from research, they are gotten from the internet, they are gotten from the textbook. So all this data coming together will make the system to have high level of expertise. And then also there is high accuracy. Then the results are consistent, meaning that if you give the same symptoms over and over and over again, you will also get the same diagnosis. Also, it consists of vast amounts of ideas and facts in the system. Then there is traceable logical solutions and diagnostics, meaning that when a diagnosis is given, the system will be able to tell you the reason behind that diagnosis. And then we have multiple types of expertise, okay, meaning that information can be gotten from different experts and then put all together in one system. Also, the system is very fast in giving response and then unbiased reporting and analysis of the facts. So unlike human being, expert system don't get tired or get emotional. So they give the accurate diagnosis or reports. Now let's look at the disadvantages of expert system. So considerable training is required before using the system. So when we are setting up the system, we have to train the system with huge amount of data so that the system can function properly and give more accurate result. Okay, the more data you use to train the system, the more accurate the result will be. Okay, also the setup and maintenance costs are very high. So to set up the system, to maintain the system is very expensive. And lastly, the information or facts entered into the system determines its accuracy. What does this mean? It means that if there's an error in the data that is input into the system, then definitely the result or the reporting that the system will give will also have an error, will not be accurate. Now, let's look at the expert system structure. So an expert system is made up of several components. We have the user interface, inference engine, explanation system, rules base, and knowledge base. We'll look at the meaning of each of the components. Now let's look at the user interface. So the user interface is the screen in which the user types in the query. Basically, it is where the user is able to interact with the system, and it has two functions. Okay, one is to accept inputs from the user and output advice to the user. So meaning that when the user wants to input the symptoms, that is done using the interface, and when the system needs to display the diagnosis, okay, that is also through the interface. So depending on the system, the user interface might involve using of touchscreen, keyboard, or even just simple keypad. For example, car diagnostic systems. Now let's look at the inference engine. So the inference engine, we say that is the main processing element of the expert system. Basically, this is the brain of the expert system, and it acts like a search engine, examining the knowledge base for information or facts that matches the queries. So it gathers information from the user, asking a series of questions and applying responses where necessary. Each question being asked is based on the previous response. It is the problem-solving part of the expert system, and it makes use of rule-based and knowledge-based to find out solution. So basically, what the system does, this component does, is that it takes the input and then it checks the knowledge base for the facts. Then it's able to also ask questions and then apply the rules. Okay, and then also based on the rules that has been applied, then it's able to draw conclusion. So meaning that it uses logical reasoning to solve problems. Now let's look at knowledge base. So we say that it is a repository of facts, meaning that the knowledge base is used to store all the knowledge about an area of expertise obtained from a number of expert resources. So basically, all the facts, all the informations that are gathered from the expertise, from research, from internet, from textbook, all of these are stored in the knowledge base. So basically, a collection of objects and their attributes. So for example, we would have objects. What are the attributes of the objects? Let's say dog. One attribute can be that the dog is a mammal, and then it can be a pet. It lives on land. It makes bark sounds. Body is covered in fur. Walks on four legs. Now let's look at rule base. So rule base is a set of inference rules. So inference rules are used by the inference engine to draw conclusion. So the rule base contains inference rules, and these rules are used to draw conclusion. Now they follow logical thinking. For example, if continent equals South America and language equal Portuguese, then the country is equal to Brazil. Just for example, here we have dog and whale, and these two are both mammal. So if the user says I need the name of an animal that is mammal and can be a pet, so it will follow logical reasoning. Okay, looks for the animal that is mammal. So we only have these two, and then it continues again and can be a pet. So this whale will be crossed out, and then our answer will be dog. So that is how rule base is used. Okay, let's look at explanation system. So this is the component of the system that informs the user of the reasoning behind the expert system's conclusion and recommendation actions. So this is the part that tell the user the logic reasoning, okay, the reason why this conclusion was reached. For example, a medical system that diagnosed mercury poisoning. So why did it diagnose that condition as mercury poisoning? Because of impaired vision, lack of coordination, weak muscles, slurred speech, and the patient used to work in a paint factory. Okay, let's supplies a conclusion and any suggested actions to be taken. So here's an example of a conclusion and actions to be taken. So it gives the percentage probability of the accuracy of its conclusion. And then based on the information given to me, the probability of finding oil-bearing rocks in location is about 21%. So it gives supplies a conclusion and then suggests any actions to be taken. Now let's look at how expert systems are set up. So to create an expert system, all the steps has to be followed. The first one is information gathering. So informations or facts needs to be gathered from human experts or from written sources such as textbooks, research papers, or the internet. Then the knowledge base is populated. So the information that is gathered is used to populate the knowledge base. Basically make it let it be in a database. Then we have rule base. So a rule base needs to be created, and this is made up of series of inference rules so that the inference engine can draw conclusions. Then next we have inference engine. So the inference engine itself needs to be set up. And then we have the user interface. So the user interface has to be developed so that the user and the expert system can communicate. And lastly, test the system. So once the system is already set up, it has to be fully tested. And this is done by running the system with known outcomes so that the results can be compared and any changes to the expert system will be made. Now let's look at machine learning and the difference between machine learning and AI. So we say that machine learning is a subset of artificial intelligence in which algorithms are trained and learn from their past experiences. So for example, in AI represents simulated intelligence in machine, while machine learning is the practice of getting machine to make decisions without being programmed to do so. So basically it's able to make decisions based on the data that is in the system. Also, AI aims to build machines that are capable of thinking like humans. So AI should be able to reason, should be able to adapt, should be able to learn just like humans. While machine learning aims to make machines that learn through data acquisition so that they can solve new problems. So they can only solve problems based on the data that is fed to the system. So that is all for this lesson. Thank you guys so much for watching. Please do not forget to like, share, and subscribe.